Hello, welcome to the lecture on polar plot. Polar plot is also a frequency response analysis technique. We already seen one of the frequency response analysis technique using Bode plot. What is a frequency response analysis? I can simply say I will be varying the omega. That's I vary the sinusoidal input. I will check the response. That is called frequency response. That is, I will be substituting in place of S j omega, and I will be getting a complex number. I will take the magnitude of it, and I will take the phase angle of the complex number. And if I plot the magnitude versus omega, I say it's a magnitude response. If I plot the phase versus omega, I say it is the phase response. Together it is called frequency response. Okay, this is an overview. And in polar plot, we'll be seeing how to use a polar graph, how to plot the frequency response, how to find the gain crossover and phase crossover frequency, and what about the gain margin and phase margin. Welcome to the lecture. Polar plot. Right? In polar plot, it is based on the polar coordinates of any complex number. Right? If I take a complex number a plus jb, it can be represented in polar form as magnitude and phase angle phi. Magnitude is represented by r, phase angle is by angle phi. What is a magnitude? It is a real part square plus imaginary part square. What about the phase angle? It is tan inverse of b by a. Here a caution is required. Suppose if the real part is negative, if the real part is negative, if the imaginary part is positive, we know it is in the second quadrant. In that case, we have to introduce a correction, pi minus tan inverse of b by a. Similarly, if it is in the third quadrant, that is real part is negative as well as the imaginary part is negative, there we have to introduce a correction, pi plus tan inverse of b by a. Why we are introducing these corrections? I have explained in another video in the channel Fundamentals Learner, working with complex numbers. You can clearly see that. But as of now, have a caution that whenever the complex number is coming in the second quadrant and the complex number is the third quadrant, we have to work in this way. We have to, if it's second quadrant, we have to make it 180 degree minus tan inverse of b by a. If it is in the third quadrant, 180 degree plus tan inverse of b by a. If it is in degree, if it is in radian, I have to use pi. This is very, very important, right? Don't confuse with don't confuse radian and degree. Okay, because if I say pi radian, that is equal to 180 degree. We are going to work with a calculator, means we should ensure that we are putting in the right mode. If we are putting in the degree mode, we have to use 180 minus or 180 plus. You should not use pi there. If you are using radian mode, you should not use 180 degree, right? You should use pi or minus pi or plus pi. Okay, right. Now in the calculator, there is an inbuilt option called polar to rectangular conversion, rectangular to polar conversion in the scientific calculator. If you straight away use this method, we need not to worry about these things, right? Tan inverse, well, we're using tan inverse of b by a only. We have to worry about the second quadrant and third quadrant, right? While you are using polar to rectangular conversion or rectangular to polar conversion, you need not to worry about anything. You will get the correct answer, right? Okay. Regarding this explanation, I gave it in that another video lecture in the channel. Please look at it. Now this is the polar chart or polar graph, I can say. Here you can see the concentric circles. These are called concentric circles, right? So many circles are there. Okay, and we can see the distance between the circle is constant. Distance between the circle is constant, and I use this circle as for the magnitude, right? Suppose if I say the magnitude of this circle if I say is 2, What is the meaning? Everywhere it is 2. If this circle is 2, what is the magnitude of the next circle? Magnitude of this circle is 4. For the next circle, the magnitude would be magnitude would be 6. Okay, so the magnitude is represented by the concentric circles. Next thing, we'll be seeing the radial lines. What is a radial line? The line which are going outwards are called radial line. It is used to represent the phase angle either in degree or radian. In the graph, things are given in degree. You can either use radian, but to be convenient, we use degrees here, right? To mark an angle, we use degrees. Okay, and we can see the constant radial lines, right? What is a radial line? The line which is going outwards. You can see the line coming outwards, right? These are radial lines. So if you uh, look at this is 0 degree, this is we can see in anti-clockwise the degree is positive 0, 30, 60, 90, 120, 150, 180. And suppose we are having the degree in negative, means this is 0, this is minus 30, minus 60, minus 90, minus 120, minus 150, minus 180, minus 210, minus 240, minus 270, minus 300, minus 330. This is minus 360, or I can say 0 degree or plus 360, all are same. Okay, right? And you can look at the number of divisions between these. Okay, and you can equally divide the angle. This is minus 90, this is minus 20. The in between radial line should be 30 degree. So this should be around um, minus 105 degree, right? So the point you have to remember is the concentric circles indicates the magnitude which is evenly spaced. The lines which are coming out, they are called radial lines, are used to represent the angle. So if we are going to plot the magnitude and angle in this plot, okay, this plot is called polar plot. Now we will refresh again. What is a frequency response? We are taking a transfer function, um, 2 into s plus 2 divided by s square into s plus 1 into s plus 3. Here the important thing is we will be seeing something called type number, type and order, right? What is type? Type is nothing but the number of poles at the origin. Okay, if you can see here, how many poles at the origin? S square. So 2 poles at the origin. S is equal to 0, S is equal to 0. So type is 2. What is an order? Is the total number of poles of the transfer function, right? What is the number of poles? Because what are the poles here? S square. So S is equal to 0 is one pole, S is equal to 0 is another pole, then S plus 1. So S minus 1 is one pole, S plus 3, S minus 3 is another pole. So totally we have 4 poles. So this is the order. So this system is type 2 and order 4. And remember that type exists only for open loop transfer function. Order is for both open loop and closed loop. Now we will move to the frequency response. In place of S, we are substituting j omega. Then I had 2 into j omega plus 2. I have substituted everything, right? Now we can take the magnitude. We have discussed in Bode part itself how to take a magnitude. 2 into square root of real part square in plus imaginary part square. Then what is the magnitude of j omega whole square is? It's root of j omega, the magnitude is omega. Since j omega whole square is there, omega into omega, omega square. What is the magnitude of j omega plus 1 is square root of omega square plus 1. What is the magnitude of j omega plus 3 is square root of omega square plus 3 square. This is the magnitude. Then what about the phase angle? Phase angle is nothing but tan inverse of imaginary part by real part. Phase angle of 2 is 0, so I left it out. Tan inverse of omega by 2. Okay, what is the phase angle of j omega? If I ask, it's minus 90 degree. 1 by j omega is minus 90 degree. Since it is 1 by j omega square, it is minus 180 degree. Then what is the phase angle of j omega plus 1 is tan inverse of omega by 1. Then phase angle of j omega plus 3 is tan inverse of omega by 3, right? So I will mark what are the phase angles, right, for here. Okay. Now, okay, we will see the significance. Why this type is very important. We already have seen what is a type. Type is nothing but number of poles at the origin. Order is nothing but the total number of poles of the transfer function, right? So we can see, well, what is the importance of type, because it types is the number of poles at the origin. It determines at what phase angle the response starts. Well, you know what is the frequency response? Frequency response nothing but we will be varying the omega. That is from omega is varied from for frequency response. I will vary the omega from 0 to omega equal to infinite. Okay. When omega equal to 0, my frequency response is starting. When omega equal to infinite, my frequency response is going to end. Okay. Now, the significance of type is it determines at what phase angle the response starts. When omega equal to 0, at what angle it is going to start. Right. Next, what is the significance of order? It determines at what phase angle the response terminates. That is at omega equal to infinite. That is why we say type of a number determines where the at what angle that plot starts. Order indicates at what angle the plot terminates. Things will become clear when you look at these examples. Look at the first example. It is 4 into s 4 divided by s into s plus 1. What is the type of the system? Number of poles at the origin. One pole is at the origin. So the type is 1. What is order? Total number of poles. So order is 2. So type 1 and order 2. Now we are interested in the phase angle, right? We are not going to see about the magnitude response now. We are just seeing the significance. That's why we are going to start, we are deal only with phase angle. What is the phase angle of j omega? Phase angle of j omega is minus 90 degree. What is the phase angle of j omega plus 1? Tan inverse of omega. We know what is the range of tan inverse of omega. Tan inverse of omega is going to vary from always 0 to 90 degree, right? Tan inverse of 0 is 0. That is why when omega equal to 0, we get phase angle as minus 90 degree. When we put omega as very high value, tan inverse, that's infinite, tan inverse of minus 90 degree minus tan inverse of infinite at very high value, I would be getting minus 180 degree, right? Because tan inverse ranges from 0 to 90 degree, 0 when omega equal to 0, 90 when omega equal to infinite. So at infinite, in place of tan inverse, I am putting 90 degree. So minus 90 minus 90 minus 180 degree. So we got an idea at what phase angle, between what phase angle my polar plot is going to, or frequency response is going to exist, right? It is between, angle is between minus 90 degree and minus 180 degree. So that is why I am marking here minus 90 for a type 1 system. It is starting from minus 90. Okay, for order 2, it is going to terminate at minus 180. This arrow indicates type 1 indicates the starting point, order indicates the ending angle. What is this angle? Minus 180 degree. So it is ending at that point. Look at the next example. 3 divided by s plus 1 into s plus 2 into s plus 3. I am writing in the frequency response. So what about the phase angle? Phase angle of j omega plus 1 is tan inverse of omega. Phase angle of j omega plus 2 is tan inverse of omega by 2. phase angle of j omega plus 3 tan inverse of omega by 3. And we know when omega equal to 0, all phase angles are 0, because we know tan inverse ranges from 0 degree to minus 90 degree. So for 0, everything is 0. So the for omega equal to 0, angle is 0. When I put omega as infinite, we know what is the maximum angle. Omega is very high value, this is 90, so minus 90, this is another minus 90, this is another minus 90, so it is minus 270. That is the maximum phase angle. So this system is a type 0 system because there is no pole at the origin and 3 total number of poles are there, so order is 3. So for type 0 system, omega equal to 0 means the starting point is 0 degree and the ending point is 270 degree. Sorry, minus 270 degree. It's nothing but 90 degree. Okay. Now we will look at some few more examples before arriving at some results. Okay. I have written some simple open loop transfer function. Okay. This is 1 by s plus 1, type 0, no pole at the origin, and one pole, total number of pole is 1. So type 0 system, order 1. Okay, type 0, order 1. For type 0, what is the starting angle? 0 degree. What is the ending angle? Minus 90. Look at this system, type 1 system. So starting angle is minus 90. Here it is type 2, so minus 180. Type 3, so minus 270. Okay, you have to be very clear. It's a simple thing. If I say something like 1 by s, its frequency response is 1 by j omega. 1 by j omega is nothing but, if it multiply with conjugates, it's minus j by omega, right? At, at what angle it is minus j? Minus j is in minus 90 degree. Okay, this is plus j omega. This is real part. This is This is a negative real part. This is your minus j omega. So 1 by j omega, for 1 by j omega, the angle is minus 90 degree. The angle is minus 90 degree. See, 1 by s square means minus 90, minus 90, minus 180. 1 by s cube means minus 90, minus 90, minus 90. So minus 270. Then what about the order? Order, it is 1 by s plus 1, order 1. So the maximum angle is minus 90. Here the maximum, this is minus 90. The maximum angle of this is minus 90. So it is minus 180. Look at this. What is the angle of this? The angle of this is minus 180 degree. What is the maximum angle of this? Minus 90. So the total angle is 270. What about this? The angle is minus 270. What is the maximum angle? This is another minus 90. So the maximum angle is 360. Okay. So we can conclude things. Type of a system. If a type 0 system, it is going to start at 0 degree. If a type 1 system, it is starting at minus 90. Type 2 means minus 180. Type 3 means minus 270. Similarly, for order 1, it is going to terminate at minus 90. Order 2, terminate at minus 180. Order 3, terminate at minus 270. Order 4, it is terminating at 0 degree. Okay. Now, this is, we will see a bit later. Okay, now we take a problem. Okay, take a problem, we will plot the polar plot, right? Let's take this problem. Let me say this is the first problem. Okay, right. G of s is given as just a moment. G of s is given as 5 divided by s into s plus 1 into s plus 2, right? Okay, so first thing we have to find what is the type number of the system, right? Type number. What is the type number of poles at the origin? Type number of poles at the origin. Type is poles at origin. So 1. So type is 1. What is the order? Total number of poles. So order is 3. Okay. So we have seen from the previous slide, type 1 means it is starting at minus 90 degree. Order 3 means it is going to terminate at minus 270 degree. Okay. Type 1 means starting at minus 90. Order 3 means it is going to terminate or end at minus 270. Roughly I have plotted this, right? It is starting at minus 90 degree, going to end at minus 270 degree. I'm going for the frequency response. In place of S, I'm substituting j omega. I got the frequency response equation. I'm going for the magnitude. What is the magnitude of phi is phi, j omega is omega. This and all is very clear for you already. Okay. J omega plus 1, the magnitude is root of square root of omega square plus 1, and magnitude of j omega plus 2 is square root of omega square plus 2 square. What about the phase angle? For 1 by j omega it is minus 90. For 1 by j omega plus 1 it is tan inverse of omega. 1 by j omega plus 2 it is tan inverse of omega by 2. Now very important thing, right? Since for university examination you are supposed to draw the graph, right? In competitive examination they will be asking a specific questions, right? In that case we are no need to draw any graph. Work becomes very simple. But in university examination you have to draw the graph. For drawing the graph, what I have to do is for finding the magnitude response, magnitude response uh, magnitude response I will substitute various omega values. I will find it. Similarly for phase I will substitute various omega values. Look at the table. I have substituted 0.1. So 5 divided by 0.1, square root of 0.1 square plus 1, square root of 0.1 square plus 2 square. I got the value 24.8. Now in place of omega I substituted 0.2. I got the value 12.2. Then in place of omega I substituted 0.4. I got 5.7. In place of omega I substituted 0.6. I got 3.4. Similarly, if I substitute 0.1 in the phase angle, I got this. 0.2 I got minus 107. 0.4 I got minus 123. 0.6 I got this. It may looking bit difficult, right? Every time I have to substitute these values. In calculator, there is an option called introducing some variables into an equation. Thereby you can solve the expression very easily, right? Now I'll explain. If you take your calculator, you can see a shift key. That is your left corner key, shift key. Next there will be an alpha key, right? You can see a red color written words alpha. Wherever you can see in a calculator color words, you can see above that angle, I mean minus sign like thing is there, right? You can see A, B, C, D, all are in red color. So whenever I press alpha and I press that sign, I will get A. Whenever I press alpha and apostrophe sign, I get B. Whenever I press alpha and then if I press HYP, I get C. Whenever I press alpha and I press sign, I get D. I press alpha, I press cos, I get E. So A, B, C, D, 4 options we have, right? So 4 variables you can enter into an expression. Now there is one thing called calc, C-A-L-C, calculate, right? Now what I'm going to do is, I'm going to, okay, I request you to all to take your calculator, and you can see here like I'm going to find the magnitude response, right? So what is expression 5? Type the number 5 divided by, open the bracket. In place of omega, you substitute A. How can I substitute A? Press alpha key and A key. A is nothing but like minus is there, no one symbol. Within a bracket minus is there. Above that we have A, right? So it is 5A square root of alpha A square plus 1 plus 1, then square root of alpha A square plus 4. Now the expression is ready. Now close the bracket. It will be like this. Okay, in my calculator it is looking like this. I just write for your convenience. It is like 5 divided by bracket a square root of a square plus 1 square root of a square plus 4. Okay, how I got this a? I press the alpha, alpha, then I can see a minus sign, and above that I have an a. This is the key, right? Here I have angle. You can see the key. Then there is a below the shift there is a key called calc. Now you press calc. It is showing a question mark. Now you substitute in place of a 0.1. You get the answer 24.8. Okay, again press calc. Now you type 0.2. You get 12.2. Likewise, you have to press calc every time, enter the value. So the best thing is type this expression only once. Type this expression. Type this expression only once. Okay. This expression only once in a calculator. Now you enter various a values. Right? If you enter various a values, you can get the magnitude. Right. Similarly, you type the phase angle. Right. What about the phase angle? It is minus 90 degree. Ensure you are using in degree mode in your calculator, right? Minus tan inverse of, what is there in place of omega? I have to put a tan inverse of alpha a minus tan inverse of alpha a divided by 2. Calc, you put the values 0.1 minus 98. Okay. Right? Minus 98, minus 107, minus 123 for various values of omega. It's very simple. Just you need to practice, right? The biggest advantage is you can type the expression only once like this, and you can substitute a values routinely. You get this magnitude. Similarly, you type this instead of omega, you will be getting in a calculator like a. Now put various values of a like 0.1, 0.2, 0.4. You get the angles, right? You got the numerical values of magnitude and phase angle. Now we are going to plot the thing. Plot it. Okay, right. Now this we are having the graph sheet here, right? This is the graph sheet, and I have pasted the same table we put in the previous slide. Okay, now we observe very closely. We already seen in our Bode plot lecture what is the gain crossover frequency, right? Gain crossover frequency, gain crossover frequency, omega gc, means gain becomes 1. Magnitude of g omega becomes 1. That is the gain crossover frequency. Phase crossover frequency means phase crossover frequency omega pc is angle is becoming 180, 180 and minus 180 both are same, right? That is your phase crossover frequency. If you look at the table values, we can see magnitude is 24, 12, 5.7, 3.4, 2.3, 1.6, 1.1. Here we are getting 0.8. So what about here? So at omega equal to 1.2, the magnitude is 1.1. At omega equal to 1.4, the magnitude is 0.8. So between omega 1.2 and 1.4, there is the magnitude of 1. Can you understand? Can you understand? Okay, that is we are looking at the values, looking at the magnitude values, we are getting 1.1, immediately we are getting 0.8. So 1 is somewhere in between. What is the corresponding frequency? For 1.2 I am getting 1.1, 1.4 I am getting 0.8. So the gain crossover frequency is between this 1.2 and 1.4, right? That is what gain crossover frequency, at which the magnitude becomes 1. Then that's what I have written. Gain crossover frequency is between 1.2 and 1.4. Next we move into phase crossover frequency. Look at the phase angles. It's minus 179, minus 186. Between these two things we have minus 180, right? Minus 179 is there, minus 186 is there. Between these two things we have minus 180. It is between what frequencies? Minus 179 corresponds to 1.4, minus 186 corresponds to 1.6. So it between 1.4 and 1.6 there exists phase crossover frequency. Okay, right. Now we are going to plot. Important thing is you look at the values of omega. So record the values of the magnitude. For us, the magnitude around 1 is very important. This range is very important. Don't worry about the higher values. Okay. So if you look at the scale, it's going 12, 24. Look at how many circles we have. 1, 2, 3, 4, 5, 6, 7, 8 circles we have. Okay. So what I am doing is I am taking the magnitude as each circle as 1. This entire circle is 1. This is 2. This entire circle is 3. This entire circle is 4. This entire circle is 5. Magnitude, right? So I am taking 8 magnitude circle. Each circle is of magnitude 1. 1 is increasing, right? Okay. Then what about the angle? Angle is of no issues for us, right? Because it's fixed, right? It's already 0 degree, minus 30, minus 60, minus 90, minus 120, minus 150, minus 180. It is increasing, right? Okay. Now we are going to plot the points. At omega equal to 0.1, what is the magnitude? 24.8 and minus 9.8. But here the magnitude we are having only is 8. We cannot plot the first two values, right? We are not going to plot the first 2 points. They are very high values. So you can just leave it, no problem. Okay. Now come to the third value, that is omega equal to 0.4. What is the corresponding magnitude? 5.7. Corresponding phase angle minus 123. So I am going to plot these two values. Okay, 5.7 and minus 123. Look at the graph. Where is 5? It is here. Where is 6? It is here. So 5.7 is in between 5 and 6. Where is the angle minus 123? Come here. The angle is minus 120 is here. This is the angle minus 150. So how many division here between these lines? I have how many divisions? 5 divisions. So each division is 6 degree. So this is minus 126, minus 132, 138, 144, 150. Okay. Now what is the intersection point? I need the intersection point between 5.7. 5 is here. 6 is here. So 5.7 is somewhere here. And I need 120 minus 123, right? This phase angle is minus 120. So 123 is somewhere here in between that. Okay. Between that, right? So I mark the point as A. Can you clearly understand what is A? A corresponds to the angle minus 123. 123 is between minus 120 and minus 126. And what is magnitude 5.7? 5.7 is between this circle is 5, this circle is 6, so 5.7 is here. Okay. Similarly, plot the point B. What is the point B? B is 0.6, 0.6 omega. Magnitude is 3.4, angle is minus 138. Where is 3.4? This line is 3, this circle is 3, this circle is 4. So it is between 3 and 4. 3 and 4, right? So I got the point here. Corresponding angle is minus 138. 138 is here. I keep a dot. Likewise, plot it C, D, E and other points. Other points are magnitude is like you see 0.6, 0.5, 0.4 and all very small. Okay, I cannot even write at all. So just keep a dot and connect the lines. Freehand you have to connect these lines. Okay, nothing wrong. And you can see, since you are working with calculator, you can put like 0.4, even you can put 0.5, omega 0.5, omega 0.7, omega 0.9, 1.1, 1.3 also, because you are working with a calculator. No need to worry about the number of values. Easily you can put the values, right? Okay, right. We got plotted. Now polar plot is completed. Now we move to the very important thing, finding the gain margin and phase margin. What is a gain margin? Gain margin is nothing but magnitude at phase crossover frequency. Okay, what is phase crossover frequency? Phase crossover frequency is the frequency at which the angle is 180 degree. Right? Now come to the graph. This is the angle 180. Okay, this is the angle 180. The corresponding magnitude. The corresponding magnitude. I can take some other color. I take a black color or like blue. Yes. My plot is cutting 180 degree. The corresponding magnitude is what? This circle is 1, mine is slightly less than 1. I can say approximately it is like 0.8, 0.8 I can say. Okay, that is the gain margin. From the graph I am saying, okay, from graph I am saying it is 0.8. Just you have to see at what point it is cutting the minus 180 degree. The corresponding magnitude is gain margin. Okay, next, what about the phase margin? We have to find the phase angle at omega gc. Right? What is omega gc? At where it is cutting in unit circle. Where is the unit circle here? This is the unit circle, right? This is the unit circle. Okay, this point cutting is here. This point it is cutting, right? I can keep like something bit dark color. I use an green. Yes, this point. What is the angle? That angle is the uh, omega phi at omega gc. Right? This is from the graph we are working, but still we can solve using the calculator. But gives the exact answer, right? You should be ready for both. So what I should do now? I am going to write the type the magnitude expression, that is 5 divided by alpha a square root of alpha a square plus 1 square root of alpha a square plus 4 calc. Right? This is the magnitude expression I have typed in my calculator. Now you see what I have said. We have to find first what is the gain crossover frequency. Gain crossover frequency is between 0.2 and 1.2 and 1.4. I am using my calculator. I substitute omega as 1.2. I get 1.14. Okay. Next I am putting calc in place of a. I am putting 1.4. I am getting 0.85. Now it is between those two values. So I am putting 1.3. I am getting 0.98. Omega gc equal to point is 1.3. 1.3 the magnitude is becoming has become 1. Using the calculator trial and error method, I have found out that value. Okay. Similarly, type the phase angle expression. It is minus 90 degree minus tan inverse of A minus tan inverse of, what about the expression, omega by 2, that is A by 2. Calc, it is between uh, where the omega PC, it is between 1.4 and 1.6. So I put 1.5. I get minus 183 degree. So I put like calc 1.45. I get minus 181. That is approximately, yes, I can write it here. At omega PC equal to 1.45, phase angle becomes minus 181, approximately 181. I can say approximately 180. So this is the phase crossover frequency. Okay. Once you found out the gain crossover frequency and phase crossover frequency, you can easily find out the gain margin and phase margin. Okay. The gain margin of the system is approximately, can write it here. Gain margin of the system is approximately like PC 1.4. It is approximately 0.8. This is the gain margin. Phase margin of the system is this is 6 degree. 6 degree. Okay. Because this value will be approximately minus 174 degree. So 180 minus 74, 174, it is 6 degree. Then we are going to conclude, if the gain margin is less than 1 and the phase margin is positive degree, it is stable system. Gain margin greater than 1, phase margin negative degree, it is unstable system. If the gain margin is equal to 1 and the phase margin equal to 0 degree, then marginally stable system. Okay, I hope things gets clear. In the next we will solve few more problems. Any doubts, please feel free to ask in the comment section. Thank you for listening.